Good evening, everyone. Today, I, Tamanna Bansal, on behalf of GirlScript Foundation, bid a warm welcome to all my attendees and my fellow teammates. GirlScript Foundation Punjab region is a non-profitable organization whose main objective is to impart technology and relevant skills. We are not a women-only organization but have equal opportunities for everyone, and thus 50% reservation is for women intact. On June 2nd, 2020, we completed our third year and so far have impacted more than 60,000 students. We have 64 national and 4 international chapters. Moving forward, our today's event is a part of GS Tech Carnival. To start with it, I would like to invite Mr. Shashank Mishra, who is an experienced data engineer with a demonstrated history of working in the IT industry. He is highly skilled in big data technologies and data visualization with a good command on languages like Java, Python, C++, data structures, and algorithm. Today, Sir will discuss as in how to start as a data engineer and what all scope do we have. Now I would like to invite Sir.
Hey, thanks, Tamanna. Thanks for inviting me. And first of
Yes.
all, I would like to thank the entire GirlScript team for giving me this opportunity to share my experience about the data engineering and to throw some light on this domain. How can someone start with it? What all things you guys need? So definitely, it's a very, very good opportunity for me. So yep, I have prepared something for you guys. So I'll quickly start with the presentation. Uh, so can you see my screen, Tamanna? Tamanna, can you confirm? Can you see my screen? Tamanna, is my screen visible?
Yes, sir, am I audible? Yes, sir, your screen is visible.
All right. Okay. So let me start with that. Uh, okay, guys. So like just a short introduction about myself. So when I started my career, I started with software engineering field where I was working as a backend data engineer, but somehow in my very first employer where I was working as a software engineer, I got to know about this big data domain because there were some projects going on, and this domain basically looks very fascinating to me. And when I got in touch with some of the seniors who are working in that company, they told me that how fast this big data domain is growing and what are the future opportunities in it. So that's why it looked very promising to me. And then at that point of time, I thought I should try this domain, and I did that. I started working on basic skill sets, and when I made my first switch in Paytm, there I joined as a core data engineer. And like my journey as a core data engineer started from Paytm, and now currently I'm working as a data engineer with Amazon. I also work with world's most number one MNC, that is, you can say, consulting based from McKinsey and Company, and did my master's from NIT Allahabad. I'm also running a YouTube channel that is e-learning bridge, where I used to call people from different companies and who have different backgrounds, college backgrounds, who are freshers, and they basically cracked some of the good tech giants. So they used to share their interview experiences on my channel to help the freshers about the entire interview process of a particular company, what is their strategy roadmap they follow to crack these tech giants. So you can definitely check that out. So our today's main agenda is basically how to start with data engineering. That is the most important part. And even before deep diving into it, I would like to clarify two things, because this big data domain is very, very vast, and obviously we cannot cover so many things in a 1 hour 2 hour of webinar or stream, something like that. So that's why first I would like to tell you guys that in this big data domain we have different opportunities for the guys who are very good in programming or technical skills, and we also have good opportunities for those people who have some non-technical skills, like they're not very much good with programming and all. So here I have listed down three very most popular profiles, that is data engineer, data scientist, and machine learning engineer. Even there are like very big confusions about these profiles, like what is the roles and responsibilities, and some of the time people think they all are same. They get confused like what are the exact roles and responsibilities of each job profile and what kind of skill set we need. So that's why I thought to clear this doubt. So being a data engineer, what they are basically supposed to do, uh, we are supposed to create basically scalable data pipelines. So I will give you a very simple example, and after listening that, you will definitely will be clear about the roles and responsibilities of a data engineer. So let's say I'm Amazon, right? And I'm working as a data engineer in Amazon. So we all know about the Amazon is an e-commerce company where lots of transactions are happening on its platform. So obviously there will be some sort of data Amazon is collecting, and at the beginning it is stored at some source location. It could be MySQL, it could be any cloud storage, or it could be any on-premises system, or it could be any NoSQL data, right? So our data is at some source, and we all know how fast data is growing day by day, right? Let's say today its size is around 1 GB, 2 GB, 50, 100 GB. Let's say in a week the size may grow up to 1 TB, 2 TB, or 10 TB, right? So this scale of volume of data is increasing day by day, and to basically gain something meaningful from that data which is raw and stored at the source, we need to bring it in our system. In bring it in our system, that means into our some you can say basically local system, so that we can perform some transformation on top of it, and we can pull something meaningful from it, for which could help the business to make data driven business decision, right? So being a data engineer, it's our responsibility to pull that data, huge amount of data from some source X, uh, and dump it into the downstream systems. And those could be anything, like again, NoSQL, MySQL, or any cloud storage service. So our responsibility is basically to write those scalable data pipelines, and to perform the transformations on the fly. Because if I'm saying I'm pulling some raw data from source and dumping it into the destination, then it has no meaning if we are not able to pick something meaningful from it, right? So somehow obviously in our organization there will be different business teams, and they would have different requirements, that you have this source data X, and you need to pull it from there, you need to perform these business transformations on top of it, that and then dump it into the downstream systems, so that our those business teams basically can perform their aggregation or their business logic on top of it to analyze the data, right? So this is the responsibility of a data engineer, to write down those scalable data pipelines and to perform the transformations on the fly. And to create those scalable data pipelines, definitely you will code something, you will be writing some logics, you will be performing some things using code and something like that. So that's why to have a good understanding of data structures and algorithms becomes a very important for a data engineer. So that's the one part. And obviously apart from that, big data is the core of each and every profile which is basically originated from this big data domain. So we will talk about in later slide, and later slides I have covered like most important terms or most important frameworks or things which like are useful for a data engineer, or like being a data engineer we should know these frameworks. So next was like data scientist. So data scientist and basically the someone who is not very much concerned about the data flow and like how we are pulling it and how we are dumping it. They are someone who are basically mathematically good, and they mostly work on some smaller set of data, because they will be writing, they will be creating some mathematical models, and in order to create that they will be working on simple test and data, and they will train their model. So to test or to train their model, they definitely do not require very like petabyte of or terabytes of data. They simply work on some smaller data sets and try to create some good fit data models or predictive models like could be anything. So they are someone who are supposed to good with mathematical concepts and modeling, data modeling, or you can say they are someone who basically write those models on top of the transform data, which was basically pulled by the data engineer and transformed by us on the fly. And there comes the machine learning engineer. So they are basically all rounder, right? So machine learning engineer is like data scientists created the mathematical model. They did it using smaller set of data, and they are done that. Yep, this is the best fit model. We can apply it on the entire data set and predict something out of that. So now there comes machine learning engineer into the picture, because data scientist has created that model, and to implement it on the entire set of data, that is the responsibility of a machine learning engineer. So that's why they are all rounder. They should have some skill sets of data scientists, and they should also be aware about the technical skills of data engineer. So that's why they are performed like a all rounder here. So next in next slides, guys, I will share some insights about the important frameworks of big data, because I said big data is the core of every profile. Even for the data engineer to become a good data engineer, you should have a very good understanding about the basics, frameworks of this big data domain. And at the end of the video, I'll definitely call out some important skill sets which are necessary for this data engineering profile. So first is like we should know like what is big data. So big data is basically large amount of data which cannot be handled by uh, traditional databases like RDBMSs and all. So they have some limitations that they can handle some limited amount of data. They cannot handle very large volume of data, which is in like terabyte and petabytes. And if I call about the characteristics of data, so in total there are 5 V's, but we have 3 important V's of big data, that is volume, velocity, and variety. So volume, that is basically the amount of data to solve. Like every problem is not a big data problem. Let's say you have a file with 10,000 records and you are trying to solve something with that, and you are considering it a big data problem. So no, it's not a big data problem. First you need to figure out whether this problem lies under the big data problem or not, and to identify that, we follow these V's. Like it should have a huge volume of data. Variety means data could be in different formats, like format, it can be like unstructured, structured, or semi-structured kind of thing. And then comes the velocity means data could be like batch data or real-time data. Batch data means you are processing data for some given time window, let's say weekly, monthly, or bi-monthly, something like that. And real-time data, you are processing it with the time, right? So that's basically real-time data. Next is like types of different data types I was talking about. So we have structured data type, semi-structured data type, and unstructured data type. And why I'm basically explaining these stuff, because That's what I said. The topic is how to become a data engineer, right? So to become a data engineer, what all basics you should know. That's what I have mentioned in this presentation. So yep, the understanding of different types of data is also very important. So for a structured data, a data type, it could be your uh, uh, CSV, or you can say RDBMS table. So that is basically structured because it has some fixed schema. It is in some row and column format. You can basically, it looks very structured, not a very complex or clumsy. And then semi-structured data, like which is basically partially organized. That may A very good example is XML and JSON. They are basically semi-structured and schema-free. Like at any given point of time, you can add any tag, or you can add any field in the given file format, which is XML or JSON. And unstructured is basically the data type which has like no schema. It is like the structure is not fixed. And the example is basically audio file, video files. Next is basically, this is very important point. We need to understand like why data is the new oil. So basically, this is the best definition because data has been compared with the oil. So, and why it has been compared with oil? Because data is, first point is like, data is an essential resource that powers the information economy in much the way that oil has fueled the industrial economy. So obviously data means some useful information. That's why it is powering the information economy the way oil is basically powering the industrial economy. Second is, information can be extracted from data just as energy can be extracted from the oil. So the similarly, we extract some meaningful insights from the data, and in the similar fashion, we extract energy from the oil. Third is, data flows like oil, but we must drill down into data to extract value from it. Data promises a plethora of new uses, diagnosis of diseases, direction of traffic patterns, etc. Just as oil has produced useful plastic, petrochemicals, lubricants, gasoline, and home heating. So we all know, if we filter the oil, and then at different stages of filtration, we will be getting different products. So in the same way, the like how deep we drill down, or how deep we will dive into the data extraction, definitely we will be able to extract something meaningful at every stage. That's what I have mentioned here. Like you can use data, like healthcare data, to figure out some patterns to diagnose different diseases. You can analyze the data, the traffic data, for like direction of traffic patterns, something like that. So at every stage of extraction, you can create or you can basically predict something different from the data. And the life cycle of oil is defined by process, obviously extraction, refining, and distribution. The life cycle of data is defined by relationships with other data, with context, and with itself via feedback loops. Next is like traditional oil powered the transportation era. In the same way, the data as the new oil is also powering the emerging transportation options like driverless cars, hyperloop, which are based on advanced synthesis of data in form of algorithms and cognitive knowledge without use of fossil fuel. So yep, that definition is also correct. Like the way oil is powering the transformation era, in the same way our data is powering the new or you can say powering the emerging transformation options like driverless cars, or using some AI, ML. So that kind of stuff we are doing with data. That's why it is the new oil of IT industry. Next is basically distributed computation and distributed storage. So in the distributed computation, obviously, like we know, we have a single machine. Let's say you have your laptop, and you want to compute something. Let's say you have a 1 GB of file. Definitely you can write some program. It will take some time, but you can write code to produce some output from that 1 GB of file. But let's suppose if this data size get increased, let's say 1 TB or 10 TB, then obviously it cannot be handled by a single machine, right? So because every machine have some capabilities that at some point you can add the external hard disks, RAM, and these stuff, but beyond that you cannot add, or you cannot scale the capacity of your machine. So that's why this distributed computation came into picture, where we basically connect or accommodate different machines, commodity hardwares, to create a cluster. And this cluster basically helps to solve any problem in a distributed fashion. So this is being called as a distributed computation and distributed storage. So these two are very, very important term, or you can say basically a base of every computation engine we use in big data or in any profile as a skill set. So distributed computation was one, and their distributed storage. So that's what I said. And nowadays, basically, we want those systems where data, which are basically fault tolerant. Let's say something happens at any particular time with the machine, because those are physical machines. Any accidental thing can happen and you may lose the data, but we do not want that, because data is very, very important to us. So that's why and obviously what I said, a single machine have some capacity. Let's say a single machine can extend till let's say 5 TB, right? So if you have a data set whose size is greater than 5 TB and all that, you cannot restore it in a single machine. So that's why this distributed storage came into picture, where we basically split our input file in smaller chunks and store it in different regions, or different machines who are located at different regions. And even those basically splitted parts are replicated on different regions and different machines, so that we can achieve the fault tolerant. Means if something happens with the one region of server or one region of machine, still we have the backup of our data. So next is basically vertical scaling and horizontal scaling. This also becomes a very, very important part, and it is the important part of any system designing thing. Doesn't matter if you are writing a web application, creating a web application, or any solving a big data problem, then these two topics becomes very, very important. We need to handle the scalability, right? Because nowadays like data size is growing, and even if I talk about specifically the web application, the user requests are increasing at any particular point of time. So we are supposed to create such systems which are highly scalable, so that at any particular point of time our system is not broken. So here vertical scaling basically means we are trying to increase the capacity of a single machine, right? So as I said in my previous point, every machine has some capacity. Beyond that, you cannot add any external component into it to increase the capacity. So this is vertical scaling, where we are only trying to increase the capacity of single machine. And next is horizontal scaling. In horizontal scaling, what we are trying to do, as per the requirement, we are trying to add the external commodity hardware in the existing cluster. So let's say I started my business today, and in the next 1 month, I am only handling, let's say, 50,000 customers, and I'm only handling the data of 50,000 customers. So obviously, I would require only 2-3 machines to do the computation part, and we are done. Let's say my business started growing, and every day customer base is increasing, and let's say after 2-3 months I am handling, let's say, 10 million of customers, 100 million of customers, then definitely I need to scale my system so that I could accommodate the increase or the high spike in the incoming data. So that is basically horizontal scaling. Means based on the time requirement, we are adding external commodity hardwares in our system. Next is, this is the very, very important framework, guys. everything started from here, first with like distributed computation and all, and then this came into picture because we would have required some frameworks which provides all these stuff like distributed storage, distributed computation, and monitoring the resources, right? So here Hadoop came into picture. Hadoop is a framework that allows you to first store big data in distributed environment so that you can process it parallelly. And it has basically very three important components: HDFS, MapReduce, and Yarn. So what is HDFS? HDFS is basically nothing. This is a basically mechanism which allows us to store our data in splitted format. So most of the like what are the things to store the data in a distributed fashion? The HDFS is one which provide all these facility, and it is the component of Hadoop framework. Next is basically MapReduce. So MapReduce is nothing, basically a methodology. So when we talk about the distributed computation, so when this framework was written, so they came up with the approach like, if we have a big amount of data in distributed environment, then how we will be computing it? Because let's say there are four or you can say 10 partitions of input file, and every partition is stored at different machine. Then definitely, let's say if we are performing any computation, then every machine will generate its local output. All right. And we would expect the we would expect the final result. So in this MapReduce computation, or you can say this methodology, the idea is basically process the data and process basically our application or the code we have written, process it locally on different machine, and whatever output will be generated, we will combine it together and give the user as a final output. So that is the whole idea behind this MapReduce concept. Then basically comes the yarn. So we know we have a huge cluster of machines, like different commodity hardwares. So every hardware have some resources like memory and RAM. So, and let's say like we are running multiple codes on this single cluster, right? Let's say I am writing and submitting one code, my teammate is writing and submitting one code, and somebody else is writing and submitting a code on the cluster. So then definitely there should be someone who should allocate these resources properly, like to process my code, what amount of memory I should provide from the cluster to this client application. So this is the responsibility of Yarn. So it is basically a resource manager. It keeps a track of all the available and occupied resources of our cluster, and accordingly it assigns to the different client applications. Next is, this is a, like guys, a very hello world kind of example of this MapReduce thing. So here our main idea is to compute the frequency of each word which is present this input file. So here let's say welcome repeated one time, Hadoop repeated 3 times, class repeated 1 time. So the problem statement is we have an input file and count the frequency of every single word using the MapReduce code. So the MapReduce part, how it works basically. So this first step is basically the mapping part, and this second phase is basically the reducing part. So in the mapping, what will happen? Basically, our data is stored in the form of blocks in the different machine, and we call it as a input split. So there will be one map task for every input split, and we will be writing our logic. So here the logic is simply break the sentence into words and write value 1 in front of it. So the output of map task will be the key and value. Like here key is the word and value is 1. And then after that, obviously to find the frequency of every word, we need to accommodate it, we need to group it together so that we could calculate how many times Hadoop was present in the input file. So here we will be shuffling the data across the network so that we could collect all the keys which are of same type at same reducer. So here you can say, see, after the shuffling, all the keys which were present in the mapping task, they were present at different machine. But after shuffling, they are present at a dedicated reducer. So here Hadoop key Hadoop is present here, good is here, is here. So now as a in the reducer task, we will simply group by it to take the final count. So that's how basically a simple map reduce methodology works in the distributed computation. Next, another basically very important framework, and this is, I would say, a must to know thing to become a data engineer, and a very must to have a skill set to look for different opportunities in the IT industry. So guys, the problem with the Hadoop was basically it was good fit for the batch processing only, right? Because there were map tasks involved, there was a reduced task involved. So whatever will be the output of map task, it will get spilled into some external hard disk, and then our reducer will read it from the external disk. So their computation time was very high because we were reading data from external disk and it was flowing across the network. So that's why it was good fit for the batch processing, but not very good framework to process the thing in real time. But nowadays we all know the importance of real time data, and what is the use of real time data. So we obviously would have required a framework which can perform the things in the real time. So there Apache Spark came into the picture, and the feature of Apache Spark is basically it is polyglot. I mean, you can code in Spark in different languages, and that was not basically was possible with Hadoop. Probably it was like mostly it was in Java or Python. And here this one Spark is polyglot, like you can code in Scala, you can code in Python, you can code in Java, you can code in R. And speed, second basically advantage of having Spark was speed. Obviously Spark is basically 100 times faster than Hadoop, because what it tries to do, it tries to compute the things in memory. And we all know if the data is in memory, then seek time would be very less and we can quickly perform the computation. And that was not the thing with the Hadoop. It was not doing the thing in memory. That's why its speed was slow. Now, next was the powerful caching. So Spark basically provides good caching mechanism and persistence. So let's say you have written some application where you are doing some iterative kind of operation on a particular data set again and again, right? So in Hadoop, there was no mechanism to cache that iterative part, right? We need to compute it again and again. But Spark came with this feature that if there is some data set or any transform data set you want to use again and again, you can cache it, you can persist it. And next is deployment. From deployment perspective, it is like very easy. So if I talk about the different components of Spark, so there are like 5-6 important components of Spark. So first is basically Spark, Apache Spark core APIs. So let's say if you are good with the technical terms and you are someone who love to work with the inbuilt methods and inbuilt libraries provided by the Apache, and you want to code something, then Spark core APIs are available there. You can create your application, Spark application, using this core APIs. If you are someone who are not very good at using core APIs, or not very good with like writing programs, then but you are very good with the writing SQLs. Let's say you have some logic which can be written by the program and you can also write it in the SQL. Then Spark provided us the Spark SQL library, There you can compute everything, write your logic in the form of SQL, and Apache Spark will convert it into the distributed code, and it will do everything for us. And there, if I was talking about that, it is good fit for the real-time application, real-time data processing. So there are libraries, or there are basically abstract data types which can help us to perform this Spark streaming or the real-time data processing. Next one is basically MLlib. Let's say you are someone who want to perform some machine learning kind of algorithms. Then we have MLlib. If there is a problem use case where you want to solve or something like that in a graph architecture, then GraphX is here. And next is SparkR. So guys, I was talking about this batch versus real-time processing. So batch processing, I told you guys that let's say you have a data with some specific time window, let's say weekly, bi-weekly, or let's say you have decided some time window. Let's say after 2 days I will process that file. If data is not collected till the 2 day, then means it haven't reached that threshold. So that's what basically the batch processing means. So here in the diagram, you can see that the collection and storage of data for processing at a scheduled time when a sufficient amount of data has been accumulated. So in the flow, you can quickly see you transaction collected, transaction file created, transaction file stored, master file updated at the scheduled time period, right? So that's what we are collecting something in the batches. Means after the specific amount of time we will process the data. Till that time period we won't process it. So the good example is the check clearing system and the generation of bills. So we know about the electricity bills. Basically, the time period is monthly. Like when the month end will be there, we will basically produce the electricity bill for you, and you can pay it. And credit card transactions, obviously there is a monthly time limit, like you transacted something in the given month, and at the end of the month we are supposed to pay the bills, right? So next is basically real-time processing. Here whatever we are receiving, instantly we are processing it. So that is basically real-time processing. And the best example is basically, you can say, the Twitter now. Like we know about the trending hashtags, which hashtag is trending. So the Twitter, what is doing, they on the real time they are capturing the data, like in fractions of seconds they are capturing the data, and they are combining and looking the data, what is the frequency of the hashtags which are basically are written, or you can say over the Twitter platform. So they are capturing the data in the real time. Similarly, like Instagram feeds, like they are changing with the, like every seconds, the likes, YouTube views. So these are basically the data set which is getting processed in the real time, right? And another example is like the reservation system. So that is obviously, like both of the pipelines, like batch pipelines and real-time pipelines, are always hard to create. But the major challenges we face with the real-time processing, because there are so many things are involved and we need to take care. So this is like a very basic example of real-time processing data. So here guys, you can see we have some source, and in the middle we have some mechanism. In the middle we have some mechanism to process the data in real time, and at the end you can see some dashboards are creating, means which are either getting updated by the real time data. And the best example is basically the cricket. I mean, we used to watch cricket, and there we can see like uh, the pie charts, right, which are getting updated after every over, and we can see bar charts which are getting updated after every over, right? So that's basically something you can relate with the real time data processing. Like they are processing some data in the background, and they have created some dashboards on top of it, which are getting refreshed with in a real time. So here from the source we are aggregating, we are collecting data from different sources, and we have different frameworks available to collect data from different sources. And Kafka, guys, this is one of the like messaging queue kind of thing. So obviously, when we are processing data in real time, then production and consuming speed may not be similar. So let's say producer is producing the things very rapidly and fastly, and our consumer is uh, basically not matching the speed, then definitely it will for consumer it will take some time to process the thing. So meanwhile, whatever data we are getting, we need to put it somewhere, we need to hold it for that time, so that in the next iteration we can pick that data and process it. So that's why we would have needed some queuing mechanism. So Kafka does it for us. So it's a basically messaging system. So here, whatever data we are getting from the source, our producer is collecting it and putting it into the Kafka topics. And there you can see Spark streaming, what we looked at the previous slide. So using the Spark streaming libraries, we are processing this data in real time and like sending it to the downstream systems, where we can create historical dashboards which may get refreshed after weekly or monthly, and we are also refreshing our data, some of the dashboards in the real time. So next is guys, what is NoSQL databases? This is also one of the most important thing we should know as a data engineer, because we know about the traditional, or you can say transactional databases, but they have some limitation, they have some limited capacity. We cannot solve big data problems using the transactional databases. So in order to perform analytical queries, which are basically compute heavy, and where basically we need to store the data in the distributed format, right? So for that we have those NoSQL databases, and the idea behind it, basically they do not support ACID properties. They are just to hold the data, they are just to hold the large amount of data in different fashion, to so that we can perform heavy analytical computing queries. And there are different kind of NoSQL databases which have different approach to store the data, so that our computation speed is very fast. So that's why NoSQL becomes very important in the picture of big data. So if you are someone who is basically interested, or literally looking forward for these profile, at least for data engineering, then you should have, apart from the like transactional databases, you should have a good understanding of these NoSQL databases as well. So next is like type of NoSQL databases. So we have four types of data NoSQL databases. One is like key value, like where data is stored in the form of key value, and the example is basically Redis, Memcached. Next is document based, means those NoSQL databases where we store data in the form of documents, and the very good and popular example is MongoDB. Next is columnar databases, like where we store the data in the form of columns instead of the rows. So the best example is HBase, Cassandra. And next is basically graph based. So let's say you have a data set which have some hierarchical kind of relationship, and you want to store it in that fashion. Then you have NoSQL databases which are of graph type. So the best example is Neo4j FlogDB. So this is again the very important point. Like we all know, guys, the importance of cloud services, right? So like like every enterprise, every company is looking forward to move their solution onto cloud, because there are so many things involved with the cloud services. They like so many advantages they provide us. And similarly, big data, that is also very much dependent on cloud, That's why we are saying big data and the cloud, a match made in heaven. So big data project typically get started with data storage and application of basic analytic modules. So, right. So, however, as you discover ways to extract data at a much larger scale, you will need to find better methods to process and analyze this data, which will likely require infrastructure upgrades, right? So, you may add more capacity to your in-house data warehouses or power up more servers to cater to the rapidly increasing analytics requirements. But even with the boost of your on-premises systems, your infrastructure eventually may not be able to keep up. This is where the cloud comes in, or more fittingly, when your big data goes to the cloud. So there are two terms involved, on premises versus cloud, right? So most of the times, obviously, to solve these big data problems, we prefer this cloud services. And why? Uh, that I will try to explain with some comparisons. So in on premises, basically, you are maintaining everything at your own end. Let's say you want to create a cluster, you are buying external commodity hardwares, you are setting up everything by your own. You have different people who are managing these admin accesses and all these stuff. They are looking into it, they are managing the servers, right? So that's why high hardware cost, medium backup cost. Obviously, let's say whatever, like there could be possibility some like accidental things may happen with the cluster or with the on premises machines or the servers, right? So in that case we may definitely lose our data, and if it happens, then that means we have lost everything. So that's why the like backup thing is a very bottleneck in this on premises systems. And next is basically high maintenance cost. Obviously you require you need a very good maintenance. You time to time you need to do the cleanups and all, and so many different things to make that on premises up and running for 24 into 7. And here the cloud services, what are the advantages? Like obviously low hardware cost, like in comparison of on premises, backup and recovery. So your data is safe, means if there won't be any chances that you are losing your data if something happens with the cloud services that are being provided by the providers. Let's say something happened at their end, but they have created these mechanism that your data is in the backup, right? And next is basically security compliances. Obviously in the on premises there is always a big chance that some loopholes, and like data security is very important nowadays. No enterprise or any company wants that uh, they do not want to do any they want to don't want to compromise with the data security, right? Because we know how important it is. So that's why like to maintain those security features on parameters in the on premises system is always hard, because we may miss some points, but that thing we like we can take care in with the cloud services very easily, and our data is basically very safe there. And some very popular basically cloud service providers is GCP, AWS, Microsoft Azure. So that's like my recommendation. Whatever I have covered in the slides, whatever topics I have talked about, so that is completely related to the data engineering profile, and even the different profiles which are in the big data field, means data scientist and the machine learning engineers and data analyst, business analyst, right? So being a big data enthusiast or someone who likes to work in this domain, we should know these things. So that's it, guys, from my side regarding the presentation. So I would like to hear from you guys regarding the questions. If you have any, I would love to answer that. Hi Tamanna, can you hear me? Tamanna, can you hear me? Tamanna, can you hear me?
Hello, sir. Am I audible?
Yep, Tamanna, you are.
Sorry, there were some network issues at my end, so I had to like
All right.
just cut. Yes, sir. Sir, I think we have some questions in the comment box there. Down there in the
All
comment.
right. Oh my
Yes,
God. Okay.
yes, sir.
All right. All right. Let's look for the session. Okay. Okay. So one question is from the Saraswati Kumari. She is asking, is okay, what is data analyst? Is it same as data engineer? So no, no, Saraswati. That's what I was saying. Uh, Actually, there are uh, two things. Means from the technical perspective and from the non-tech perspective. So if you are someone who is very much interested for like to code the things and to program the things, right? Then there are so many technical aspects associated with it. So that's basically a role of data engineer. But from a data analyst, they are someone who are supposed to work on the data exploration or to perform any business operation or business logic on the transformed data to gain insight from it. So to become a data analyst, what I would say, you have to be very good with data exploration, means for that writing SQL queries, okay, and basic scripting, means whether you are good with shell scripting or Python scripting. And then comes the data visualization tools like Tableau, Power BI, and few ETL tools like Informatica. So this is the overall basically things required to become a data analyst. And next is Mayank from sir, how do we manage our repositories in relation to Spark and Hadoop? I didn't get this question actually. Repositories, I mean to say, uh, like it's a simple, you can use anything repo, you can create a code structure even. Uh, let's say you are using IntelliJ or something, you can create those things, and this like rest other things same. You will have your class files and you can execute it, you can pass those parameters, these things. So that's how we generally create codes in the Hadoop or the Spark application. Okay, then
Yes.
Infinity HAM. All right, nice name. So, can you explain little bit about data scientists? So, Infinity, that's what I in the very first slide I explained about it. What is the role and responsibility of data scientists? Again, I will explain. So, they are basically someone who are responsible for coming and how it should look like and all. Their role is very simple enough. They will be provided the transform data and all, and based upon the requirements, let's say someone asked to write the predictive model and all these stuff, so they will work on that transform data. They will pick different smaller data sets and write their model, or you can say basically mathematical uh, model, whatever it is, and using that test and train data, and will create those models. And then it's the responsibility of machine learning engineer to implement those mathematical models on the entire set of data.
Thank you, sir. I think we don't have any more questions now.
Okay.
And thank you for your valuable time and for making this session so much informative. I hope that our attendees have found it very helpful and there are many doubts that have been cleared from their side. Thank you so much and glad to have you, sir, between us. Thank you so much.
Thank you, team. Thank you very much for inviting me. I enjoyed the session.
Thank you, sir.
Hello, sir.
Hey, hi,
Uh,
Mitesh.
sir, last hi, hello, sir. How are you, sir?
Yep, I'm good. Yeah.
So I listen your every word, each and word about big data and engineering. And sir, the last question asked from
Yep.
Bagunas. Sir, as a bioinformatic application student, how should I approach data science? Helpful for me to start by.
Yep. So that's a good question. And like this is a very generic doubt, because as I said, like these domains are very booming and everybody is looking forward at least to have a good career in this domain. So what I would suggest to even start with the data science, your college time is very good. Uh, first you should understand actually what is required in this domain, what you should learn, what is very very important. So for that you should first, like I can tell you different skill sets and all that, but that will be like a bouncer for you, because you do not, probably you do not even know about those terms and things, right? So I would say it's your responsibility first to understand the meaning behind it. Do not only think about the data science, because there are so many things, so many profiles. I always recommend this to different students. First, spend a good dedicated amount of time, let's say 1 month, even a 2 months, to explore different fields, and then try to figure out which one is basically looking more interesting to you, which looks very very fascinating to you. Create some benchmarking, like what is the current trend for this profile in the market, and what is the basically you can say the future, what is the future of this profile in the coming 10 years, 20 years, 30 years. And if I specifically talk about data scientists, so you have to be good with the aptitude part, you have to be good with the mathematical logics, right? And these things, Mayank, you can start in your college. Do not think like that you are from bioinformatics. So I would say on my channel I interviewed one folk. So he was from civil engineering, and in the college time he had a similar condition like you, but in the college time he explored things by his own, and read all the things, practiced it, created some smaller projects, took participation on Kaggle and analytics with their, grabbed good knowledge around data science, and then got a good placement. So that's what I have named a few things, but I know it would be very very bummer for you that I bombard you with different texts. I say read this, read that. No, that shouldn't be the process. First, explore what is data science or different domains. What is looking more interesting to you, and then after that, make a roadmap for that, and then start your journey from there. Okay, we have more questions. So, Mubashira, difference between data science and data engineering. I cleared this doubt. I even started my presentation with this question. So, data engineering, I will like share this presentation with the GirlScript team. They can share it with you as well. So in the data engineering, we basically deal with the pipelines I was talking about. You have some data at source, and first you need to bring it in your system, and this is the responsibility of data engineers. They will bring, or they will pull those data sets and will perform some transformations on the fly, and make that data set available for the data scientist to perform their mathematical or to create those mathematical models. So though both of them have a very different skill sets, they are not same, they are not even overlapping, right? So based on that, like this is the difference. I would say please go through with the slides. You like your doubt will be probably clear. Oh, Harsh. Okay, what exactly is Hadoop? It's a very, very vast topic, Harsh. I just gave you some glimpse about it in the presentation, in the stream I was talking about. So it's a basically a framework, distributed computation framework, which helps us to store the data in distributed fashion, and allows us to compute the data in the distributed fashion. And the Saraswati, again, as you already told us about various role in the data field, like data engineer, data scientist, and the ML engineer. How can a fresher decide which role is best? So that's what I said. That's what I advised to Mayank, that it is completely upon us. Like you shouldn't compare yourself with someone else, that he or she is doing the AI ML, then I should also do that. No, this is not the case, because everyone has some capabilities, and we should always do our work accordingly. And it is very becomes very very important to find our interest. If we are not like we are lost. We do not know about interest, like whether I'm interested in the AIML, whether I'm interested in data engineering or in web development or in Android development. Then like even after 4 5 years you won't be able to decide your career stream. So at the early stage it becomes very very important to figure out what is your interest. First try to dedicate a good amount of time on different job profiles on different streams, and then make your interest first and create a roadmap accordingly. Next, Mayank, sir, what should be the approach for machine learning and AI neural network? Approach is very simple, Mayank. Don't get confused. First, try to explore. Do not just jump onto the fancy words like AI, ML, neural networking, data science, and all. Go step by step, because this domain and these fields are very, very vast. Even a person cannot cover in it like 2 and 3 years. Nobody can gain pure and hardcore expertise on it. Like being a fresher, being a student, it's my sincere advice, do not run behind the fancy words or terminologies. Whatever you have listened, first read thoroughly about it, what it is, how it works, and what, like why it is used. If you do not know why AI, ML, why neural network, then obviously like you won't be able to decide a clear roadmap for your job profiles, right? So please dedicate a good amount of time, read about everything, data science, data engineering, AI, ML, and everything is available on internet, man. Like you can go through it. Like good roadmaps are available, good blogs are written, and first make a very clear picture about your interest. Do not run behind fancy words. It's my very sincere advice to all the freshers, because I know AI, ML looks very very promising, that oh, like this domain looks very cool, I'll be writing some fascinating AI, ML code. No, it's not like that. If you are not sure about your job profile, if you are not very much interested, then even after 1 month you will drop your idea to jump into the AIML and will switch some on to something else. So please do not do that. Sir, LinkedIn profile necessary for job or a placement? No, it is not necessary, but it is very necessary to hunt for the off-campus opportunities. Sir, quantum computing involve which language? Quantum computing mostly been done by the Python.
Okay, so I will just request everyone, are there any other questions that you guys have, some other doubts? Because we still have Sir with us and we still have some time left. So I think you guys can come up with some new questions and Sir will be glad to answer them. So in case you guys have some new questions, do let us know in the comment box.
So Harsh, he has question how we relate web development with data science. So web development has like no relation with the data science, right? So web applications are different, and data science domain is really different. In web application, we are creating some applications which are running on web, right? And in data science, we are performing something on data. We are pulling some insights from it. So they have like if web development is A, then data scientist is Z. So like no relation between them. Infinity, sir, for data scientists, the C++ language is enough or not? Not, they are not even in the picture. Infinity, C and C++. They are not even in the picture for data scientists. Either you should go with Python or R. Infinity again, sir, AI involve Java language, but can Python? Yep, definitely. Python can help in every aspect of the big data. Sir, Python is enough for data? Yep, it is more than enough. That's what I said. Two options, Python or R.
Okay, Sir, I have a question. What will
Yep,
you
definitely.
suggest to a person? What will you suggest to a person who doesn't know Python or R? Like, it's a total beginner with the
And
languages. What do you suggest
okay,
that person?
so total beginner, but first question is whether he or she wants to learn it or not, and which profile he or she is targeting.
So that's a valid thing. But still, if like a person who is interested into going into this field,
Yeah.
but he knows, like the person knows C, C++, Java, but is not so much. He even knows JavaScripts and all. even though they are not needed. But Python and R is totally new to the person. Then what will you suggest to the person? From where should the person start?
All right. Yeah. So that's a good question. I mean, because as a fresher, definitely we would have started with C, C++, JavaScript, and all. And if we are making our career into these domains, then at least for some profiles, I would say at least for the data engineer, there is no barrier except C, C++, because they are not even very much involved in the development side. So for the data engineering profile, definitely Java will work, Python will work, Scala will work, right? And even for the other domains, the technical like data science and machine learnings, so they're like mostly, at least for the data scientist profile, they used to prefer the Python and R, and even same goes for the machine learning engineer. And I also talked about different non-tech profiles like data analyst and business analyst. So they are mostly working on data exploration like SQL and basic scripting like shell scripting and Python scripting. Now come to on your question that if someone do not know about it and it's very new, how he or she can start with it. So definitely, if someone has a programming background, like if she know about C, C++, and the JavaScript, then definitely she would know at least the logical things like how looping works, how if else works, like how to write functions, base conditions, and all these stuff. And then definitely in every language there will be some new sort of data structures, right? Like in Python we have dictionaries, we have list, we have tuples, right? So the basic approach should be basically to, there will be some challenges with the syntax, obviously you need to understand that, but the beauty is logical thing is same, you just need to work on the implementation part of it, right? So go slow. First cover all the basic things like baby steps, like how we write the looping conditions in Python, how we write functions in the Python, and then explore the different kind of data structures, new data structures available in this language and how it works. And then based upon the use cases, try to explore its libraries. First thing shouldn't be like, I'll directly jump onto the libraries, how it works. No. First thing, go with the baby steps, the understand the syntax and basic things, then its important data structures, and then the libraries.
Okay, thank you, sir. We have some more questions from Infinity HM, and
I'm still reading his questions. Interesting. Any example websites for Android development? I'm not sure what you are looking for, Infinity. Or whether if you are looking for resources, then definitely you can search it on YouTube. There are very good channels available which provide good tutorials on Android. Like if does like if does it with any other site which I'm not getting your question. Sir, R language is related to which language? Infinity R is itself a language, like it's not related with any other language. It is related to the data science domain. Sir, GitHub profile necessary? Uh, Nothing is necessary, but it always adds some value if you are using these things, because these things are used as a standard in the IT industry. So it would be good if you know about it. That's what I said. Nothing is necessary.
any more
So if you
questions
want to
from the
know,
audience?
I got it. This
I
question
think they
is
are,
also, yeah,
yeah, they are deleted. Okay.
no problem.
Well, sir, I really like that point which you just said that you should not run after the terms. You should first
Yeah.
explore about the things and know about your interest. That is very important because I remember when I was a fresher, I was the one who was running after stuff. I was like, मैं ये भी करूँगी, वो भी करूँगी, and then I
Exactly.
looked into fields, I studied about them, and now I know what to pursue. So I think that was a very nice point.
Yeah.
Yes, sir. And I think there are no more questions. Now I would like to invite Amitesh. Amitesh. Okay, sir. I think he's facing some network issues. So
Okay.
thank you so much, sir, for the session and for making it so informative. I'm sure there are plenty of questions which you have just answered them and they are satisfied all the audience. And thank you so much, sir, for your valuable time and for the information.
Thank you. Thank you, Tamanna.
Thank
And
you.
thank you, GirlScript team, for inviting me. Bye bye.